Okay, so this is the problem about the surfer going down the wave. And it should look very familiar to the block on a ramp. Same type of problem. Here we have the normal force perpendicular to the wave, and the weight is always straight down to the center of the earth. This is a problem where the surfer is going to be going down the wave, so we tilt our axis. I'm going to call this my positive x and this my positive y, which means if he's accelerating at 3.5 meters per second squared down the wave, all of his acceleration will be in the x direction. So I go ahead and split my weight vector into components. Wx is parallel to the axis, Wy is perpendicular, and this angle theta is the same as this angle theta here. All right, so I'm going to go ahead and do the sum of the forces in both the x and the y direction. The x direction is along the ramp. The y direction is perpendicular to the ramp. Okay, so in the x direction, I just have Wx equals max, which means the surfer's motion down the wave is caused by part of his weight. That makes sense. And in the y direction, we get the normal force minus W sub y equals 0. 0 because the surfer is not floating up off the water or sinking through the wave. So the normal force is equal to part of his weight. So I rewrite Wx as mg, because mg is the whole weight. And then I'm going to put, the sign of theta here, because the Wx in this picture is opposite my angle. Sine is opposite over hypotenuse. Equals ma. The mass of the surfer cancels, and so we get 9.8 sine theta equals 3.5. So sine theta will equal 3.5 over 9.8. So if you make sure your calculator's in degrees, you take theta equals the sine inverse of 3.5 over 9.8, and that should give you your answer.